What we're looking at here is the lesson 10 notes, and it's really important to pay attention to this lecture. I'm going to talk about some things, do a little bit of a review of what you should have noticed or started to pick up on, at least generically, in lesson 9. And then more information on identifying things in the periodic table. There are vocabulary terms that you will see later on in this lecture, and they are incredibly important for you to kind of burn them into your brains now, because they will become very important throughout the rest of the course, because we'll talk about where things are located on the periodic table, or just in general trends about these vocabulary terms. So this lesson, the main idea here is, what information does the periodic table reveal about the elements? Okay, so those generic patterns or trends that you should have noticed in 9, they're going to make a little more sense with this lesson. Okay, periodic table contains so much information about the elements. So what you see here, this is just a little color-coded periodic table. You'll see its bright colors. You will eventually, here at the conclusion of lesson 10, color a periodic table. You will label a periodic table. No, you're not filling in, atomic numbers and symbols and masses and things like that. But you will fill in other information on the periodic table. Okay, so let's prime the pump here. This is kind of a knockoff version of the cards that you had for the lesson 9 activity. You do want to get those out now, because you are going to have to lay those in front of you to go through some different things of this lecture. And then you'll have to get them back out to do the lesson 10 activity as well. Okay. So you'll notice some things that are kind of left off here, basically what's in the corners of your cards. Okay, and the masses are given to us at the bottom of these cards, or those decimal numbers. Okay, those masses are given to us at the bottom of these cards, because if we put them in the center of these spheres, it'd be too small. So you will see just the element symbols within those spheres. Okay, so here's the question. It says the atomic mass of silver is given as 107.9 AMUs. Okay, AMU is an atomic mass unit. The atomic mass of gold is 197 AMUs. Okay, looking at this periodic table, or looking at your stack of cards that you have, lay them out in front of you, where would you find these elements? Where would you find these two elements based on that periodic table that you created in the lesson 9 activity? Okay, so if you do look ever so closely here, I'll use blue. Okay, if I'm looking at silver, okay, 107.9. If you look at this periodic table, it's arranged by increasing atomic mass for the most part. Okay, so what I want to do, where could this be? So 107.9, well, it's going to be obviously down towards the bottom, because these numbers get larger. Here's krypton, 83.80. We get a little larger here. Strontium, indium. Well, I think this is going to be somewhere in between strontium and indium down here at the bottom, because you'll see 87.62 and then 114.8. So I'm going to guess that it's going to be somewhere in here. Okay. And then the other one we're looking at is gold. Okay. And what we notice with gold is this periodic table only goes up to 131.3. So it's going to fall somewhere after xenon, because we're looking at the mass here. 131.3 is large. And we notice we're going to have to do something here. Okay, because we're not looking or wanting that mass or this mass. So we know that silver is going to be somewhere in between these two cards, and then gold is going to be somewhere after this one. Okay. All right. Moving on. So take out your cards. Make sure they are set up like this. I'll pause for a few seconds. Obviously, you can pause this video and start it again when you have your cards out and you are ready. Okay. So looking at the cards that are in front of you, let's look at or review information from lesson 9. Okay. Let's look at some information from lesson 9. And these were kind of key points, key ideas here. Looking at your cards, there are numbers in the center of the circle, okay? You also see element symbols. So we've already identified what an element symbol is. It starts with a capital letter. If there's a second letter that goes with that symbol, it's lowercase, okay? Those numbers inside the center of the circle give us some really good information. And if we are looking at the cards in the proper way that we want them set up, like this one, that number goes up as we go from left to right, okay? And it, continues on in that pattern, okay? You notice that those circles in the center of your cards are different sizes, okay? Take a look. If I look at hydrogen compared to lithium, which is below that, so look at your cards, notice lithium has a larger circle than hydrogen, okay? And that was a pattern or a trend you could have picked up. Now, do you necessarily, in lesson 9, have to know what that means? No, but a pattern or trend that you have just from those generic cards is those circles get larger as we go from top to bottom, okay? Spikes. And so Kellen Marshall, I believe it was, had asked, what do those spikes, and he threw out some terms, what do those represent? Which out of these terms? And I said, well, that's not really important to know just yet. You'll worry about that in lesson 10, and we will get to that. But you do notice that you have different numbers of spikes. So there were different ways you could have looked at this. Everything here from hydrogen down to rubidium had the same number of spikes. And then as we go from left to right, you'll see that the number of spikes goes up, okay? And there's a pattern for that, okay? Chemical formula. Your chemical formula is in the bottom right-hand corner of your cards. And you probably notice as you go from hydrogen down to rubidium, they are forming, or these elements will bond, or they will form compounds that have the same ratios. We looked at those subscripts in lesson 6 and then kind of again in lesson 7 and lesson 8. And then we moved into lesson 9. But those subscripts, you'll see the same number of subscripts for the different elements in those compounds. Okay, reactivity. Reactivity was something that you looked at on those cards. There are different ways that you could see that the reactivity gets stronger or it increases. And in different parts of your card table, you would have seen that the reactivity decreases. Okay, so we're going from something that's not reactive to more reactive, or something that's very reactive to not as reactive. Okay, something that you could have seen in those cards. Okay, hardness and softness. That is stuff that you saw in that physical description in the top right hand part of your cards. And you saw a pattern or a trend with that, and you said, we're going from hard to soft or soft to hard in terms of each element. Again, look at your cards. You can pick up on that as well. The outline color. If you look at your cards, there are different colored outlines on the spheres. Okay, we know that the spheres themselves are specific colors, but there are some that have different outlines. Some that have black outlines, some that have red outlines, and some that have green outlines. Look at your cards and look at the physical descriptions on those different colored cards. Okay, what do all of the green outlined ones have in common? What do all of the red outlined ones have in common? What do all of the black outline ones have in common? Okay. In your lecture video for lesson 9, I pointed out when we had that stack of lithium, or sorry, we did beryllium, magnesium, calcium, and strontium. So as we go from Be to Sr, that shade of yellow changes. That also represents something for us. Darker shades are more reactive, so take a look at your cards that are more reactive there. And then that was pretty much it, okay? Different things from lesson 9, okay? And we'll go more in depth here. Okay, so take your cards, and I want you to make a gap. So make a gap in between beryllium and boron here, magnesium and aluminum, calcium and gallium, strontium and indium. Now, remember, you have 33 cards. You don't have the 34 cards that show up here. But spread these out. You're going to make a nice little gap in between those. Okay? When you make that gap, we're calling it, we're opening up the periodic table. And the reason we're doing that is we're going to accommodate more elements. There are more elements that go in between these. And think about it. Well, we said that silver would go somewhere in between strontium and indium. So we're going to make space for it. Okay. So this is pretty much kind of the organization that your periodic table is going to look like. There are 10 elements. So take a look at this, because you're going to see this again, for the next couple lessons. Look at between calcium and gallium. See all of these outlined boxes here? Those are places for missing elements, and we're not talking missing elements in terms of they haven't been discovered. They have by now been discovered, but these are element spaces that we are going to learn about. If you sit here and count these, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, there are 10 elements between calcium and gallium. Look at the jump in their masses from 40 to 69.72. Look at the jump in their atomic numbers, 20 to 31, okay? Makes sense. Same thing with strontium and indium. There is a gap here. You do have more elements that fit in here. Okay, and you're probably thinking, well, why aren't there elements between Be and B? Well, there aren't elements that fit there, okay? And that's why it's nice and snug, but there still is a gap. I like to call this, like, these are the banks of the river of boron and beryllium, okay? So Mendeleev added these other elements in, so the elements that he saw fitting in here, and we're keeping those in their specified columns that he had, okay? This is a modern day periodic table. This is actually what the periodic table looks like that you received as a handout. This is the same one that you're going to be coloring. Just a heads up, when you do go to color this, please do not use markers, because you're not going to be able to see this once you color this. We have crayons and colored pencils that you can use. You will be able to use markers maybe in some different places, like making the stair step line, if you want to identify where your liquids and gases at room temperature are. Those are different things you'll be paying attention to. But this periodic table that you'll end up coloring at the end of lesson 10 is what you will be allowed to use as your quote-unquote cheat sheet on the rest of your quizzes and tests, because I'm going to laminate it, so then you can't add any other information to it. You'll see a bunch of, like, a kind of a key or a guide in the back, as well as information for polyatomics, which we'll use later on in this class. Okay, so we're going to look at some important vocabulary terms throughout the rest, pretty much, of your presentation here. And with those, I'm going to break down more information about them. Okay, so atomic number is the first one. So you heard me talk about that as I pointed out different things on the cards or on those periodic tables so far. The atomic number is the consecutive whole numbers associated with the elements on the periodic table. Your cards that you have in front of you do not have atomic numbers on them. Since you have those paper copies, if you want to go back and you want to write the atomic numbers for those specific elements, based on looking at your periodic table, totally fine. You can totally do that. But the atomic number, we're going from 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. These are not decimal numbers, okay? The atomic number is equal to the number of protons in the nucleus of an element. Okay, so we're going to learn about protons, we're going to learn about neutrons, we're going to learn about electrons, but the atomic number tells us the number of protons in the atomic nucleus of an element. Okay, some terms here: group, period, alkali metals, alkaline earth metals, halogens, noble gases. Okay, I'm going to go more in depth with these. Okay, so this is kind of just a generic slide, but we're going to go more in depth. Okay, so take a look. Rows, or we also can call these periods. These are the left to right pieces on the periodic table. In the picture that you see here, you will notice that each period or each row is designated by a specific color. Okay. You should also notice that essentially there are 7 periods or 7 rows on the periodic table. Okay, even though it looks like the blue and the purple are down here, so a lot of people like to say, well, no, there are really 9 rows. They're not. This little gap here opens up to give us these different rows that we'll talk about in a little bit as well. Okay, elements in the same periods show a pattern. So with your activity, you're going to look at patterns that go from left to right on your periodic table, and then we're also going to talk here in a second about patterns that go from top to bottom. So make sure you're kind of picking up on those on your cards, okay? As we move from left to right on the periodic table, so from left to right on a row or a period, conductivity and reactivity change. Pay attention to those on your card. You pretty much just have reactivity, not conductivity. And the elements become less metallic, okay? We're going to talk about metals. Columns or groups that we have on our periodic table are from top to bottom. Okay, elements in a group have similar chemical properties. You can pull that up by looking at the corners of your cards. Notice here, the groups are designated by similar colors. Okay, these are just groups. Okay, similar colors. Elements in the same group or the same column have something that is referred to as the same number of valence electrons. Okay, we'll take a look at those cards that you have. What do you notice? Every card in the same column has in common. You should be saying the number of spikes. So what then does the number of spikes represent on your cards? Think about it, put 2 and 2 together here, okay? All right, so main group elements are groups 1A to 8A. So if I look back to this, when I'm talking about my groups, these ones that I have colored in, we call these main group elements, and you'll notice there are 8 of them, okay? Main group elements. There are 8 of them. So red on this picture is 1A, and the purplish, pinkish color is 8A. Transition elements, we'll talk about those in a little bit. The elements in groups 1B to 8B, and those are the groups or the columns here that are all white, okay? This would be 1B, this is 8B. If we have 1A through 8A and 1B through 8B, we have a total of 18 groups on your periodic table, okay? Lanthanides and actinides, these are 2 rows of 14 elements each that are placed separately at the bottom of the periodic table. That is where you see the blue and the purple that are kind of offset from the rest of the periodic table here. Okay, I kind of like to think of them as Alaska and Hawaii when you think of a map, because a lot of times you'll see Alaska and Hawaii placed in the same exact place on the map, and please do not think that Alaska and Hawaii are even remotely next to each other, okay? All right, so metals, let's talk about metals. These are elements that are good conductors of heat and electricity. They're shiny and malleable. That malleable word means that they're flexible, so there's another, I guess, another vocabulary term that you can look at there. They are found to the left of the stair-step line, okay? They are found to the left of the stair-step line. What is the stair-step line? Well, let me, what is this going to be? Stair step line goes right here on your periodic table, okay? It generally separates the left-hand side and the right-hand side of the periodic table. The metals are found to the left of it. The non-metals, which you'll see here, are to the right, and then those semiconductors, or we can also call them metalloids, which here you'll see with the key, these are pink, sit on top and on the bottom of it, okay? Non-metals, again, these are the yellow parts here on this periodic table. They sit to the right of the stair-step line. They're poor conductors of heat and electricity. They're generally dull and brittle, so that means they can break. They're not shiny. They're found to the right of the stair-step line. Okay? Metalloids, or we can say these are semiconductors. These are those found between metals and non-metals. They share some properties of metals and non-metals. They're found along that stair-step line. Okay? So let's talk about some different specific families on the periodic table. Again, vocabulary term here. These are the alkali metals. They're found in group 1A. And everything in group 1A except for hydrogen is considered an alkali metal. Hydrogen is actually a non-metal, but it's grouped with that first group because it shares properties with those alkali metals, okay? These are very reactive, especially with water. Typically soft, shiny white metals. We can cut these. These are not very dense, okay? There is a video that I'll pop up for you guys to watch about reactivity, and you'll see all this stuff break and shatter and all that great stuff, okay? Alkaline earth metals, these are found in group 2. These are silver colored. They're more dense. They're not as reactive as your alkali, but they still are reactive. Your transition elements or your transition metals, these are found in groups 1B to 8B. Or if we look at the periodic table as a whole in terms of 18 groups, these are found in groups 3 through 12, okay? They typically have 1 or 2 valence electrons, but we can't really predict those just by looking at their position on the periodic table. That's why transitions are a little harder to work with, okay? Mostly silver in color. A lot of them are reactive. We find iron, gold, silver, copper, zinc, nickel, platinum. All of those are found here, okay? More about those transition metals, those 2 rows that we saw pulled out below on that previous periodic table that we've seen that was full of colors. These are the lanthanide and actinide series. We also can call these intertransitions, okay? So the lanthanides are the rare earth metals, and the actinides are typically really radioactive, not easily found in nature. A lot of these you will see can be man-made, okay? Halogens. The halogens are elements in group 17, or we can also say that this is 7A. These are all non-metals. We can find these as solids, liquids, or gases. These are very reactive with anything that's found as an alkali metal. Chlorine is one of those. We know chlorine can be a liquid. We also know that chlorine can be a gas. Okay? The noble gases. Okay? And you'll notice that I spelled noble wrong. I don't know why. I guess I'm thinking of Nobel Peace Prize. But I'll fix that. So let me do that here so I don't look so silly. There we go. This is group 18, or we can say that this is 8A. They have 8 valence electrons. Helium does not have 8 valence electrons. Okay, it actually has 2 valence electrons. But again, it fits the other patterns or trends here. Okay, these are non-reactive. They're all gases. Okay, all non-reactive, and they are all gases. And that is it. So you want to take all of this information and utilize it as you're going back through the lesson 10 activity and coming up with some answers. You need to have those cards out in front of you. You're going to sort them out. You're going to come up with patterns and trends. So you're going to look at trends from top to bottom. You're also going to look at trends from left to right. Okay, so use your information that you had in lesson 9 and make it make more sense. So you have to be more specific here. Okay, do not just write down number on the cards. Well, what number on the cards? Okay, there's one. What did we say that number is called? We've called that what? The atomic mass, right? That average atomic mass. What happens with it? Give me information as I go from left to right. Give me information as I go from top to bottom. Okay. You have some diagrams that you have to put some numbers or some arrows on based on what you read off of your cards. Okay. Identifying where different things are located on your table. Okay. Looking at reactivity. You have to look at those colors, red, green, and black, in terms of the outlines of the spheres to decide if things are solids, liquids, or gases. Okay, you're going to look at some chemical formulas and identify metals and nonmetals, as well as metalloids if you have them. Okay, and then you're going to create a card for a specific element.